Well, hello everyone. Welcome to another We Need Our Space live from my house in Denham Springs, Louisiana. Representing the Louisiana Art and Science Museum and the Irene W. Pennington Planetarium. Shrinking myself down just a little bit here. Well, last week we interviewed Connor Mathern about his astrophotography. And I realized that we haven't really gone over the summer nighttime sky in quite some time. And we have some new things to talk about, namely the Perseids meteor shower and the recent launch of the Perseverance Martian rover, the Mars rover from NASA. So we're going to do a little bit of a refresher on what you can find in your summer nighttime sky, how you can use those objects that you can find. So let's begin, huh? Now that we're all kind of filed in here and settled in, make sure real quick that everything is still, the stream is still healthy, and we are good. Again, we are on Twitch, Facebook, on LESM's Facebook page, and YouTube. So in all those cases, if you want to subscribe to the YouTube channel or like and follow the LESM Facebook page, you'll get these updates on when these shows are live. They will be every Thursday, though, at 7 o'clock. With that out of the way, let's get right into our nighttime sky, because right now, outside, it looks a little bit like this. It is now 7 o'clock at night. The sun still has not set, but as the sun is approaching the horizon, we're seeing this over here, little Jupiter. Well, not very little. Jupiter is coming over there on the southeastern horizon. Let's speed up time a little bit to go 1 hour ahead. There we go. This is around the 9 o'clock time. So let's keep it there. That's a good time to keep it. I'm going to get rid of these markers up there. All right, so once the sun is completely set below the horizon, you can go outside, take a look up into the space above and see 3 very bright stars. You're going to find something called the Summer Triangle. So we're going to find a couple of constellations and then use those constellations to find other things. So when you go out tonight, and if it is clear enough, look up for 3 very bright stars. Those stars are going to be almost directly overhead. You're going to have Vega. Now, when you go outside, you're not going to have these names up there. This is just for our convenience. Vega, you have Altair towards the bottom, and then you're going to have this bright star, which is going to be called Deneb. So each of those stars is the brightest star in their own constellation. Now, these 3 bright stars compose an asterism called the Summer Triangle. Just want to make sure you can see my cursor here. Now, there is a difference between an asterism and a constellation. A constellation is one of the officially recognized configurations of stars in the sky. There are 88 officially recognized constellations. An asterism is an unofficially recognized pattern of stars. It can be part of a major constellation or it can be part of several constellations. In the case of the Summer Triangle is composed of 3 constellations. You have Vega, which is the brightest star. The brightest star in the constellation Lyra the Harp. Altair down here is the brightest star in the constellation Aquila the Eagle, and then you have Deneb, which is the brightest star in Cygnus the Swan. So, you might be wondering, why on earth do we have these particular patterns that we all kind of recognize and know about? Now, before we get into that, I do want to bring up something right around here. I mentioned the Summer Triangle is an asterism. You might be able to recognize this. This might help you find the Summer Triangle. This is the Big Dipper. The Big Dipper is an asterism. It is not an official constellation. It is part of a major constellation called Ursa Major the Great Bear. So this Big Dipper will be easy to find. If you can find that, you can use the Big Dipper to look over towards the left over here, towards the southeast. You can find the 3 stars in the Summer Triangle. Well, why do we recognize these 3 constellations, these 3 figures? Well, they're not just some random things We didn't just randomly pick the name Aquila or Lyra or Cygnus. They do have some historical meanings to them. So let me talk to you a little bit about the meanings of these constellations. So let's start with Aquila the Eagle. Now, most of the constellations, in fact, about 50 of the constellations are going to be named after the ancient Roman, Greek, and Middle Eastern kind of myths and legends at the time. Most of them will be the Greek ones. These particular ones deal with the Greek mythology. This is thousands of years ago. Well, Aquila the Eagle has a bit of a dark history. Now, Aquila was the pet of Zeus. Zeus was the king of the gods. Now, many thousands of years ago, people believed that there were certain gods that presided over certain aspects of life. There was one god that was overlooking the oceans and the seas, and then there was a god that was the god of war. You had the god of fire. You had the god of health. You have the king of the gods, Zeus. In one region you had Zeus, and then you had another region that would recognize the king of the gods as Jupiter or Odin. So many cultures saw different gods for different things. So these three here are associated with some Greek mythology. So Aquila was the pet eagle of Zeus. In fact, Aquila would often carry the lightning bolts for Zeus. In one story, Aquila was sent to retrieve this boy named Ganymede. Zeus took a favoring for Ganymede. He wanted him to be his cupbearer, this guy that would just kind of bring this cup around for Zeus, apparently. So yeah, he decided to pluck this kid out of off of Earth and bring him up to Mount Olympus so that he could sort of serve Zeus, and that was Aquila's job. Also, there was this figure known as Prometheus. Now, Prometheus was on Mount Olympus, and you look down, and he had this love for mankind. Prometheus saw that mankind didn't have fire. So, Prometheus took it upon himself to steal fire, stash it inside a stem, and steal it from mankind. Well, Zeus found out about this and didn't like people going behind his back, so Zeus decided to take Prometheus, chain him to a rock, disrobe him, and then every day have his eagle Aquila attack him. Now, Prometheus was immortal, so over the night, whenever Prometheus would sleep, he would heal himself. But come the next day, Aquila would attack Prometheus again. Eventually, Hercules would rescue Prometheus. But that is the story of Aquila, and that is how Aquila got into the sky. When it comes to Lyra the harp, Lyra is named after this instrument called a lyre, L-Y-R-E. Now, this harp was said to be, well, the harp Lyra here in the sky is dedicated to the harp that was owned by Orpheus. Orpheus was this famed musician. He had this beautiful singing voice. He was an amazing musician. So fantastic that he could even charm the gods. Well, one day, the wife of Orpheus was bitten by a snake, and she died. So Orpheus took it upon himself to go and try to retrieve her from the underworld. He took his lyre, and he went into the underworld, and then he charmed the gods of the underworld to bring his wife back to Earth with him. So they agreed to this, but they said, you can leave here with your wife, but on one condition, you cannot look back at her and look upon her until you have finally left the underworld. Orpheus agreed to this, and unfortunately, as he was leaving, he couldn't help himself. He looked back to his wife. As he looked back at her, he broke this vow, he broke this contract with the gods of the underworld, and she faded off back into the underworld. He was very distraught over this, so he took his own life to be with her yet again in the underworld. Because of that, Zeus took his lyre and he put it into the sky to commemorate his wonderful musicianship. Now, when it comes to Cygnus, that is actually Latin for swan. And this swan in the sky is dedicated to Zeus because Zeus, along with two other gods, but mainly Zeus, was known to be able to transform himself into a swan. In fact, he would often transform himself into a swan to woo certain women that he liked. I don't know why turning yourself into a swan would win you favor with the ladies, but Zeus would often do this. In one case, He fathered 4 children, 2 of which were Clytemnestra and Helen of Troy. Well, because of this particular configuration of stars here was dedicated to Zeus and his ability to transform himself into a swan. That's the story of our summer triangle up there. Now, this is about an hour after sunset, and just below the summer triangle you can find 2 planets. You got Jupiter and you have Saturn. You might not be able to see the Milky Way over here. To the left of the Milky Way, you'll find Jupiter and Saturn, and as midnight approaches, you have let's see here, 10 o'clock, you've got 11 o'clock, you've got midnight. So as midnight approaches, you've got Mars right there, right under Pisces. So you've got Mars, Jupiter, and Saturn. You can find Jupiter and Saturn right by Sagittarius, but we will go back to Sagittarius in just a little. Let me back up time a little bit here. Okay, so let's visit these planets up close. Well, we'll visit a couple of them. So let's go visit Jupiter, the king of the planets. Here we are at planet Earth. So let's make a trip over to Jupiter because there are some things that we can discover over in Jupiter. So let's make our way there. Travel faster than the speed of light to get to Jupiter. King of the planets, named after the king of the gods. The equivalent of Jupiter would be Zeus that we just talked about here. Now here we are at Jupiter. Let's speed up time just a bit so we can get some motion. Actually, I don't like it rotating that way. Let's look at it from this angle. There we go. I like it rotating to the right. We all have our... Okay, there we go. Speed up time just a bit so that we can eventually see the red spot of Jupiter. Jupiter is very beautiful. These colorful cloud bands along the surface there. These brighter areas are the hotter gas rising up to the surface. The darker regions are the cooler gases sinking below the surface. Well, Jupiter is the largest planet in our solar system, so big you could fit all the planets within it. It is a gas giant, though. There's no place to land. In fact, all the planets beyond Mars are going to be gas giants. Jupiter, Saturn, Uranus, Neptune, gas giants. And then you've got the dwarf planets such as Pluto, Hawaii, and Makemake. Those dwarf planets are all terrestrial. But here we are, finally at the great red spot. So let's just kind of slow down time here. Let's get close to the red spot. See, the red spot here is so large. It's been raging for about 150 years. It's like a hurricane. It is so big, though, you can fit 2 planet Earths side by side. At one point, you could fit 3 planet Earths. But it is so big, you can fit 2 planet Earths side by side in this red spot. Now, if you look down here, you will see these white circles. Now, these are known as the pearls of Jupiter. These are a lot like the Great Red Spot. They are counterclockwise swirling storms. Very, very lovely here. Let's get a little bit closer there. Now, we're not going to see these things spinning, but we get a better vantage point here of those pearls of Jupiter. Well, Jupiter has around 53 named moons with about 26 other moons awaiting for official names. So scientists think that Jupiter has around 79 moons. Now, the Juno spacecraft has a device on it called the Juno Cam, and it was able to capture these images of the Jupiter atmosphere and the clouds. Now, you can go to NASA's JPL website. There's plenty of these incredible pictures of the Jovian clouds and storms. Look at that. Some of these areas here are larger than planet Earth. It's almost like the artwork where you would put ink into other chemicals to create these lovely shapes in liquid. But again, this is the surface of Jupiter. Now, when I say surface, it's the upper atmosphere of Jupiter here. Let's back away a bit from Jupiter now. You can see these moons Bright moons reflecting the light of the sun as time goes on, and they orbit around this huge planet here. Well, the Juno spacecraft also found about 0.25% of water in Jupiter's atmosphere. Now, this is more than scientists initially expected, but bringing up water, and Saturn is the next planet on our trip away from home. We're not going to go to Saturn. We're going to visit a moon of Saturn called Enceladus. I brought up Enceladus before in the past, but oof, here we are at Enceladus. Very quick trip to there. Now, one question I usually get about the moons of Jupiter and Saturn is, why don't the moons of Jupiter and Saturn bump into each other? Well, they actually are quite far apart. Whenever I travel to these moons from place to place using this program here, of course we have to travel faster than light to get there. We will be waiting for a very long time. So no, the orbits of the moons of Jupiter and Saturn aren't even nearly close to each other. But here we are at Enceladus. This is a very small moon of Saturn. It's around 310 miles in diameter. It's very smooth. In fact, this surface of Enceladus is ice. It's said that this surface here is around 20 to 25 miles thick. Underneath that surface is said to be an ocean, a liquid ocean of water, about 6 miles deep. Now, I know that this doesn't look smooth, but if you were a huge giant like Galactus or something, and you were to pick up and look at Enceladus, it would appear to be as smooth to your touch as a pool cue ball. Let's get a little closer here now. Sorry. Get a little closer to Enceladus. I think it's pretty cool looking. It's a little bit like our moon. Now you see these little errors in the graphics there. Whenever satellites go by to take pictures of these things, you know, sometimes it's not perfect, but we do see these ravines, these craters along the surface of this icy surface. This is not like the moon with its regula. Now also, Enceladus has these ice geysers. It's kind of like an ice version of a volcano. It erupts icy particles into the upper atmosphere of Enceladus, and then it turns into snow and then rains down, but the atmosphere is so weak that these icy particles become so small. When they settle down back into the surface, they're as fine as talcum powder. Back. So again, let's keep with this motif of water here, because we're going to travel to Mars now. Mars is the other planet. So again, you have Jupiter and Saturn. Saturn has Enceladus, and then you've got, towards midnight, you've got Mars over here. So one thing I want to mention is that as midnight approaches, you can find Mars, a very bright red object. Don't mistake Mars for this star over here, which is Antares. Cover that in a second. But right now, let's go focus on Mars. So recently, July 30th, there was the launch of Perseverance, which is going to be going to Mars. It landed on February 18th, 2021. It's going to be looking at the surface of Mars, and trying to determine if life ever existed there. Of course, we do want to visit Mars one day. I'm going to rotate around here because there's something I want to show you. Yes, here it is. So as Mars approaches its nighttime, this huge gash here along... let me slow that down. There we go. This is a huge cavern. A huge canyon. Now, we have the Grand Canyon here in the States, but this canyon here on Mars is so large. In fact, let me reverse time a little bit. I don't think it's going to let me. This whole gash, this whole canyon here is so large you could fit the United States or Australia from one end to the other. It's said to be formed either during the cooling down process of Mars and the surface cracked, or they do think that something huge might have hit it one day. Brushed along the surface of Mars to form that. Now, as this Velos Marineris disappears into the nighttime sky, we see these 3 dormant volcanoes here. And then to the left of that is this location, Olympus Mons. This is a shield volcano, a dormant volcano at this point. This is the largest mountain in our solar system, Olympus Mons, Mount Olympus, home of the gods. Now, it's named after the Mount Olympus, the fabled home of the gods in the ancient Greek myths. This is not actually where Zeus lives. But this is so large, this Mount Olympus, you could fit one state of Louisiana right there. And then you could take another upside down Louisiana and put it right there. So large you could fit 2 Louisianas right on top of that huge shield volcano. Now there is said to be some ice water located along the poles of Mars and also underneath some of the soil. There has been some muddy, brackish water located on the Martian surface, kind of flowing down the hillsides during the Martian summertime. So, yes, we did launch another Martian rover to Mars called Perseverance, and this launched on July 30th. Now, we talked about this last week with Connor Mathern because he had a bit of a say on, he had a bit of an opinion on where this Martian rover should land. Now, they decided to choose a crater called Jezero, but I want to play a little bit of a video for you. This will, I guess, better describe what this rover looks like and what it's going to do. So I'm going to take myself out of this picture here, and I'm going to show you this. So check out what Perseverance is going to be doing.
You know, Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
The Perseverance rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled. The crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
This is a wonderful place to live for microorganisms, and it is also a wonderful place for those microorganisms to be preserved so that we can find them now so many billions of years later.
There is no other place on Mars that has the unique combination of a lake setting, a beautifully preserved delta, and the diverse mineralogy that we have in Jezero Crater. So it's truly a special landing site.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance rover starts with a design that's very similar to Curiosity, but we've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures.
We're going to be taking microphones with us. For the first time, we're going to have that human sense on another planet.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, the name of which is now Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
So what Mars 2020 is going to do is to drill samples, put them in small tubes. We're going to seal it in its own individual tube. We set them on the surface to provide a target for the second 2 missions, which hopefully will get in development in the next several years and could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration on Mars.
All right, so there you have it. There is what Perseverance is going to be doing. So let's move on past that now. Take a look at our sky one more time here. And so once again, there is Mars over on the eastern horizon. You find that around the midnight hour. Okay. So like I said before, you have Mars over here on the eastern horizon, and then you've got way over here, just as it is about to set around the southwestern horizon, you have this star, Antares. Often mistaken for Mars. In fact, the name Antares means the rival of Mars. If you have Ant-Ares, it means the opponent to Mars, or the opponent to Ares. Ares is the counterpart to Mars. So that is what the name means, Antares. So let's visit Antares, shall we? Let's go visit it because it is a really cool thing to look at. Here we are at Mars. We're going to leave Mars and go visit Antares. Lovely star. Center on it. And let's go. And I think as we go to it, we will go through this really cool molecular cloud. Let's see if we do that. Oh, here it is. Whee! Going through that. And we have two stars. Antares is a double star system. Let's take a look at what these two stars look like. The 15th brightest star in the sky, Antares, is the brightest star in that constellation, Scorpius, the Scorpion. It has that reddish-like appearance. You have that reddish glow there. Very similar to Mars, often mistaken for Mars. Now, whenever we look at it in relation to its companion star, this main sequence star down here, Antares B, hopefully you can see that. Yeah, I'm not blocking it. Let me just shake myself a little bit. There we go. Well, Antares A, the one that you pretty much predominantly see, that is going to be a red supergiant. It's actually approaching the end of its life, and it is one of the largest stars you can see with your naked eye. It is so large that if you were to replace our sun with Antares, the diameter of Antares would stretch out past the orbit of Mars and approaching the orbit of Jupiter. It's huge. Now the other star down here, Antares B, is a bluish-white main sequence star. Now we covered Mars constellations. We have Mars over here. You have Jupiter and Saturn over here. Well, what else is coming up in the sky? Well, on August 11th, that is going to be the peak. Oopsie-daisy. Oh, I need stars. That is going to be the peak. Something called Perseids meteor shower. So let me turn on that. Let's be a little close here. So this is going to be on the northeastern horizon. This constellation Perseus. Now, in order to find Perseus, kind of hard to find, but it is easy to find the constellation above Perseus, which is going to be Cassiopeia. Let's take a look at those. There's Perseus holding the head of Medusa. Now, if you've seen Clash of the Titans, you know Perseus is the hero that slayed the Gorgon. Medusa used her head with the snake hair to turn the Kraken, or Cetus, the sea monster, into stone. Well, he has been immortalized in our sky. There is Perseus. Right above him is going to be Queen Cassiopeia, the mother of Andromeda, who was the woman that Perseus rescued. So, let me see here in relation to where the Big Dipper is at. Okay, yeah, so there's the Big Dipper, kind of low on the horizon there. So if you kind of take the two stars in the cup and kind of bounce it up, wink, and then hit Cassiopeia, and then it falls down, and then you'll see Perseus. Well, right up here, you see the Perseids. Well, the Perseids meteor shower is coming up. In fact, it's going on right now. But the peak of the Perseids meteor shower is going to be August 11th through the 13th. So, let's talk a little bit about the Perseids and how you can find this. Now, this is a beloved meteor shower, and you can see this worldwide. And you can typically catch around 50 meteors per hour during this peak time. So, a good time to catch these would be around midnight or in the early morning hours. Now, the meteors are going to appear to originate from the constellation Perseus. That is why they are called the Perseids. Now, they can appear anywhere in the sky, but right above the constellation Perseus is where you're going to kind of get the radiant. You're going to get most of the meteors right there. Now, hopefully, I'm going to keep it right here. Now, hopefully the software will generate for us a meteor or two as I talk about this. So let me discuss the Perseids and how you can find them and the origin of the Perseids. Well, the Perseids originate from the debris field from the orbital path of Comet Swift-Tuttle. Every year, our Earth crosses into this orbital path of Swift-Tuttle. Now, the debris from this comet litters this comet's orbit. But we don't really get into the thick of the comet's rubble until after the first week of August. In fact, let's take a look here at where Swift-Tuttle is at right now. I'm going to go back to planet Earth. And I'm going to back away. Let's take a look at the orbits here. Back away from our planet Earth. There's Earth. There's our moon. Speed up time just a little bit here. We have orbits of Mercury, Venus, Earth. There's Mars. I believe that's Ceres right there. Is that Ceres? Yep. And there's Earth. Oh, that's Mars. That's Earth. Again, there is Jupiter. There's the orbits of the moons of Jupiter. And then as we leave Saturn, there's the orbits of the moons of Saturn. So you'll see that the moons of Jupiter and Saturn aren't anywhere near each other. So where is Swift-Tuttle right now? I need to put in its official name here. There it is. That red line there is Swift-Tuttle. So here, actually, that is the correct time right now. Let's go around to here. There, see what that... Oopsie daisy. Okay. So see this red orbit line there? That is where Swift-Tuttle is at right now. And you have Mercury, Venus, Earth. Now you can see that Earth is at its closest approach to that orbital path of Swift-Tuttle. So we are going through that debris field of Swift-Tuttle right now, approaching the densest part of that on August 11th through the 13th. So that is where Swift-Tuttle is at right now on 2020, August 7th. I'm sorry, August 6th. So Swift-Tuttle's orbits... It orbits the Earth, orbits the Sun every 133 years. So every year it passes through the solar system, and as it does this, the Sun heats it up, and it softens the icy particles that kind of hold all the clumps and debris and all the particles together. And this causes it to release fresh comet material into the orbital stream. So as we pass through this path, we run into this debris field that the comet has left behind, and this debris burns up in our atmosphere, causing this shooting star look. Let me go back to the... so that maybe we'll see a shooting star. So these bits and pieces left behind by the comet hit our atmosphere at about 130,000 miles per hour. So yeah, these aren't actually shooting stars, but they are meteoroids burning up in our atmosphere. And by the way, the difference between a meteor, a meteoroid, and a meteorite is this. You've got meteoroids are objects in space. They range from the size of a grain of sand to the size of an asteroid. And whenever a meteoroid enters the Earth's atmosphere, they are called meteors. So when a meteoroid survives the trip through our atmosphere and it hits the ground. Now you have a meteorite. And there you have the difference between a meteoroid, a meteor, and a meteorite. Now, how do you photograph this? Now, also, I do want to kind of mention the reason why we see them as these bright streaks in the sky is because as they are traveling through our atmosphere, they're going so fast that the air in front of the meteor doesn't have time to move out of the way as it is passing through. So this creates a huge amount of friction. This heats up, and then this burns, pretty much burns most of them up. So that is why we see them as streaks in the sky. They're burning up through the atmosphere, and that's why we see them as shooting stars. So if you're like me, you'd want to photograph a meteor shower, right? So in order to photograph a meteor shower, to catch a meteoroid, or to catch a meteor as it is streaking through the sky, it's a little difficult at times. So these meteors only last for about a second. Now they're in the dark of night. It's hard to pinpoint exactly where they're going to show up. So it's kind of difficult. So here's what you have to do to photograph a meteor. You have to go to a dark location. It does help. If you have a DSLR camera like me, this helps as well. Not that you can't use a cell phone. If you do, you'd have to kind of go from your auto mode to your pro mode and change your aperture to kind of what I'm about to talk about here. But you have a better chance catching it with something like a DSLR camera or something where you can go into a manual settings. So go to a dark location, use something that has a wide angle lens, some type of lens that catches more of the sky. You want to have more of the sky in your frame to maximize your attempt to catch something in that frame. So some type of wide angle lens, you're going to use a wide aperture, something that's inside the lens that opens up very opens up very wide. It lets in more light. So if you have a wide angle lens, a wide aperture, you're going to want to go into live mode. You're going to focus on the brightest star you can see. The way I do this is I go into my live mode on the viewfinder there. Go to about 10 times magnification for the brightest star I can see, and then I manually focus on that star so that it's less fuzzy, and trying to focus on that one star that I can find to make it as close as a sharp pinpoint as I can. At that point, once you have your focus set, you're going to set your ISO to something about 1600, or I usually go a little bit less than 1600 depending upon where you're at, depending upon what kind of light pollution you have in your area. And do some test exposures. Do some test exposure shots. Take a series of test shots at around 10, 15 to 30 seconds. It's going to be dark outside, so you're going to need more time for your camera to open up its shutter to let in more light to be exposed on the sensor and then to close. So take some test exposures, see what kind of works best for you. Try to get your histogram on your camera. This is a little representation of where the light falls on the bright end and the dark end. Try to get your histogram kind of a third of the way over from the left-hand side. Set your camera to the RAW format. This will be no compression. Your RAW format is the way to go. Don't shoot JPEG. Turn off your long exposure noise reduction. This will help you maximize how many pictures you can take. And then find the Perseids constellation and your camera towards the Perseids constellation, somewhere in between Cassiopeia and Perseids, above the northeastern horizon there, and start snapping away. So this again will be on the lower northeastern horizon, and there you go. Hopefully you will be able to catch some Perseids this year, especially if the full moon or if the moon is not anywhere in the sky. Whenever the moon's out and it's particularly bright, it's kind of hard to catch the stars. It tends to wash out the stars when you're doing long exposures. All right, so that's about it. We have covered our nighttime sky. We have covered our constellations you can find. Look at the summer triangle. Let's go back over here. Your summer triangle is going to be your Aquila the Eagle. You'll find Altair, Vega, and Deneb. Sagittarius and Scorpius right beneath that. Over on the northeastern horizon, you'll find Perseus and the Perseids meteor shower. And towards midnight, you will find Mars. So, I hope you enjoyed this tour of your nighttime sky and some updates about what is coming up. Thank you for joining me tonight. And I will see you next week, Thursday at 7 o'clock.